Awesome.
Give it
So,
up for Nathaniel.
thank you. So I've actually had this title slide made for about a year now, probably more, but I never got around to actually making a presentation about cloud security. Then Expel gave their talk last week, and they talked a lot about the cloud and how an attacker can move through it. And that kind of inspired me to talk about it and actually finalize this presentation. So we're just going to talk about what IAM is and how it's really important to cloud security, and why you don't see a whole lot of buffer overflows and like super low-level AWS exploitation stuff. It's mostly misconfigurations, over-privileged accounts, that kind of stuff. We're going to talk about why that is and how you can solve it. First of all, who am I? I'm here because I love to give presentations. That was on the template, and I didn't change it because it's true. Yeah, I present a lot. It's a lot of fun. I blog at scriptingislife. I retweet at scriptingislife. And I have a project called Glimpse ID, which will take in a URL and output a screenshot and some other information about it. That runs entirely in AWS. That's how I learned a lot about this, was through that project. I gave a talk about it last semester, about the whole architecture of it. But that's how I learned a lot of this stuff. So what is the cloud? We hear about it a lot of AWS. I'm partial to AWS. I use that for a lot of stuff. They give me a lot of money. So I use that. That's why the theme is the AWS colors rather than Azure, Google Cloud. But the cloud isn't just these cloud service providers that give you VMs and cool stuff to build applications. In the enterprise, it's also a lot of software as a service stuff. So Office 365, which you may use, G Suite, which we use for RIT. Salesforce has hosted stuff. We all love Duo. So these stuff are also in the cloud. And as an enterprise, it may or may not make it really hard to secure these applications. And there's a lot of other stuff that is maybe considered the cloud by some companies. If you ever used Box or Dropbox in an enterprise network for hosting all your important files, you have to secure that as a security team. Skype for Business, G Suite we talked about, a lot of stuff. So a few definitions that I may use, just because these are the applications that I use a lot in my projects. So if I mention them and you don't have a lot of experience with cloud, just know that EC2 is Elastic Compute something Cloud. Elastic Compute Cloud, yeah. It's basically a virtual machine. It lives in the cloud. You just spin up an operating system. You can SSH into it or RDP. And yeah, it's your entire operating system in the cloud. S3, you probably hear a lot about in the news with S3 buckets. It's technically key value storage. You can use it just to like store raw bytes. A lot of the times it's used for like file storage, but there's a lot more you can do with it. And then DynamoDB is a NoSQL database. It's super simple. It's made by AWS, and I've used that in Glimpse for storing all my information. So why is cloud and security important? Well, your company's data is in the cloud if you're using it, and that has to be secured in some way. Otherwise, you'll probably end up in the headlines like these companies. Also, some companies are spending a lot of money moving to the cloud because it's the next big thing. For example, Lyft is planning to spend $300 million with AWS through 2021. I think this was, March, so about 2 years. And yeah, your enterprise, your C-suites down to your managers all want to use the cloud. They're spending big money on it. And you have to make sure it's secure because they're going to do it no matter what. So why is it so hard to secure? We hear about S3 buckets being leaked all the time, sometimes with super secret information. Why couldn't you just turn that off? Simple answer, it's not that hard to secure. It's just different than what you normally think of with traditional IT. Your normal security measures, like your perimeter firewall, aren't going to cut it in the cloud, especially if you're using software as a service stuff like Office 365. You can't like put a firewall around Office 365 and expect it to protect your data. This is an XKCD. somewhat relevant. So this talks more about like endpoint or end user security. So like people coming into your house or your office and stealing the passwords you wrote down. This is more of like for what we're thinking, like someone like exploiting some buffer overflow in your application, or like doing cross-site request forgery on your web app. In the cloud, a lot of it's just public S3 buckets, overprivileged accounts, just weird stuff that you don't normally think about before moving to the cloud. So what's different about the cloud? Well, the first thing I think of is the speed of it all. So with DevOps and automation and all that, stuff is changing rapidly. Developers can just spin up a new instance, whatever they want. They don't have to wait for IT to create a VM in their data center or rack an entire new server, complete that purchase, hook it up to your electricity, install an operating system, all that. You can just click a button and it's there. And they didn't have to ask anyone to do it. There's also a couple different as-a-service things. The main three are infrastructure as a service, platform as a service, and software as a service. I've already mentioned the latter. There's also like every noun as a service now. And we'll talk a little bit about what those are and how they're different. And there's different security considerations you have to take for each one. And finally, there's no rules. Like I said, developers are really taking over the cloud. They aren't really asking IT for a lot now. You don't really want to do that because you don't want to slow them down and have them get angry at you. So you just kind of let them go free, build whatever they want, and you have to end up securing their mess. So as a service, this is a really good graphic I saw. I think it was from a DEF CON talk or a Black Hat talk. But pizza as a service. So traditionally, when you're using your own data center, your own office servers, you have to provide everything yourself. You're buying the electricity and the utilities to power your servers, all the way up to serving the application and interacting with the end user. Now, infrastructure as a service is like EC2. So they provide you everything up to the operating system. After that, you can come with your own ingredients, your own software. You can make it, and then you serve it however you want. Now, platform as a service comes all the way up to your electricity and your gas. So this time, you only have your application, and you don't really have to mess with the lower operating system at all. You just kind of set it up, configure it, and it's ready to go and serve to end users. And then software as a service, you're not really messing with anything technical. You aren't serving an application. It's mostly just a bunch of configuration options, and you visit a website or whatever, or have application on your computer, and that's it. There's not a whole lot there that you can customize, make your own. So what is IAM? The whole topic of this presentation. So it stands for Identity and Access Management. It's basically controlling who can access what for what means. So in AWS, it encompasses your users, your groups, your API keys, roles and policies, and a million other things. And especially in AWS, I'm not too familiar with other cloud providers, but it's everywhere. You can control everything with IAM policies. So like every resource, every EC2 instance, Lambda function, Docker container, whatever, can have a role and permissions set to it for what it can do and how it can interact with the rest of your environment. So roles, like I said, it's like a user, but can be assumed by anyone. It's not just users, it's also resources. Your actual EC2 instances can have a role attached to them. And it can be used by multiple people. It's kind of like doing su in Linux. You can just change to a different user. And like I said, it's everywhere. Every resource I've seen gets a role. I just learned that EC2 can get a role, and it's really useful now that I know about it. And I'm sure there's a million other things that have roles that I just haven't used or looked into or needed to. Then there's policies. I couldn't come up with a super good definition about this. They just define permissions for an action. So like you can read from this database table. And then roles are made up of different policies, and you can attach a bunch of different actions to a policy, attach a bunch of different policies to a role. So access keys. These are your literal keys to the kingdom. So there's a couple different ways you can interact with AWS. So through the console, just logging in as a user. There's the AWS CLI, so there's an actual AWS command that you can type, and it has a bunch of the same functionality. You can like spin up Lambda functions, EC2 instances, just by typing a bash command. Then there's the API. You can actually like make web requests to it. And the last two use API keys for that. So you can create a user, give it some API keys, and be off on your way. So the console actually gives you a bunch of good information about your access key usage. So it shows you how old it is. So like I have a couple that are many days old, up into the like 300 days that I should probably rotate or I don't use anymore. And then it shows you when it was last used. So I got really scared because it said my Nathaniel keys were used today or yesterday when I was making this presentation, and I hadn't done anything with AWS. So I got really scared. I was like, who's using my API keys? How did it get used? But it was actually just me logging into the AWS console to take this screenshot. So we're all good there. And then the last column is multi-factor authentication that you can enable on any account, which is pretty cool. So one cool story. Back in 2014, there was this company called CodeSpaces. They did like Git hosting basically, so like GitHub, but not as cool. Apparently some companies used them. And one day, their AWS console, it wasn't like the official console, but I guess they had some kind of management application that had some permission to interact with AWS that they did everything through. An attacker got a hold of it, and they basically held it hostage and said, pay us however much money, I don't know, a couple $1,000s, and we'll return access to you. And they didn't want to do that. They didn't want to pay. And so they just started trying to log in other ways, or tried to revoke access from that. But the attacker had put in a couple other backup accounts, changed some things, and they couldn't get him out. So he got pretty mad. He was like, why are these guys kicking me out? I just want some money. And so he started deleting things. And by the end of it, the entire company was gone. All user data, client data, all backups, everything was hosted in AWS. And yeah, the company ceased to exist after that. Yeah, that's why you should never use the root user on your AWS account. Yeah, that's a pretty extreme example of access keys, but yeah, if people do get access to your keys, it can have some pretty devastating effects. So why is this so hard? Why couldn't they just make a user that had the permissions that they needed and remove the root user, and it'd be all good? You would have a company that was still somewhat successful, and you wouldn't have to tell everyone that your entire company got deleted in a day. Well, it's complicated. It's literally complicated. So for example, S3 buckets and public access. So when you create an S3 bucket, there's this block public access tab, basically, that talks about all the different ways you can block public access. So there's like block access to buckets and objects granted through access control lists, granted through any access control lists, new public policies, a bunch of stuff I don't really understand. If I want to make something public, I'm just going to turn it all off. Doesn't really matter. Then there's access control lists. So this just shows like the bucket owner. You can have other AWS accounts. Fun fact, you can set it to any AWS account can access this, which like maybe if you work in an enterprise, you'd think, oh, anyone in my AWS account can access this. But actually, it's anyone authenticated to AWS. And then there's public access, which has like list and write, and then read and write permissions, but there's no like read object. I'm very confused by S3 still, and I use it a lot. And then there's log delivery stuff too. Here's all the available options for read permissions for an S3 bucket. There's a lot of stuff that I don't know, I never even knew existed, like, where is it? There's something about legal. I don't know. But really, if you want to grant read access for a bucket or for a resource to read a bucket, you really just need get object. There's nothing more that you need. None of these other policies matter. Same thing for write. There's all these different ones. Like you can get the bucket object lock configuration. Oh, there it is, get object legal hold. I don't know what that is. You really just need put object, and that's it. But you would have never known that. Maybe you just click write. I don't want to break my application. I'll just give it all the right permissions. So why is it hard? Well, the main thing is it's preventive. So like I just said, I don't want to break anything. Maybe my developers need something. Maybe they're working on an application and they may need some action in the future. So I don't want to break that and have to deal with that later. So I'll just give them all the permission they need. Yeah, it's pretty hard to like put in preventive measures. You really want to go for detective or so you don't get in trouble. Another cool thing that I just learned about a couple months ago was the metadata service. So if you're on an EC2 box and you curl 169.254, 169.254, you can get a bunch of information about your EC2 instance, like the host name, the public IP, the private IP, a bunch of stuff. And this is really nice if you're like spinning up a bunch of boxes and configuring software on it. You don't have to like hard code things, or if you're doing logging, you can attach the instance ID to that log, and it's really dynamic, and it's really helpful as a developer. But you can also do some pretty cool stuff as an attacker, like get tokens to use AWS. So this is one of my EC2 boxes that acts as an open email relay and catches spam mail and uploads it to an S3 bucket. And so this EC2 instance has a role that is allowed to write to that S3 bucket. And so I can curl for IAM security credentials and then get some AWS tokens that I can use to write to that S3 bucket. So that's not super damaging. You can write some bad data to it. You can't read anything. But if you're a big company like Capital One, say, and you grant read access to all of your S3 buckets for an EC2 instance, that could be pretty detrimental. So in this case, there was a web application firewall that left server-side request forgery through, which basically lets you make web requests based on or from that EC2 instance. So some attacker could basically make web requests to this metadata service, get AWS tokens for this role, and they could assume that role and exfiltrate all S3 data that they had access to, which was a lot. It was like 100,000 social security numbers and like 1.3 million like records of PII of people who had applied for credit cards. So yeah, this is a pretty cool example of working through an attack in S3 or AWS and kind of combining different access to different resources. So what's the solution? There's a lot of different stuff that we just talked about. How can I fix it? How can I secure it? Well, the first thing is cloud especially. You can't just drop in your SIM, start logging stuff from AWS, and expect to be a cloud expert. You really have to pay special attention to it, especially if you're doing different things with different clouds. They all have their different services and special names for weird stuff. I don't get it. Just name it what it is. Then, of course, least privilege is the best privilege. Only grant access to things you need. And we'll talk a little bit about how you can do that without breaking things. Also, monitoring your API usage. AWS lets you do a lot of cool things with CloudTrail, which basically logs every action a user takes, every change in your environment. So you can log that, and there's a bunch of tools for detecting things in that through those logs. Of course, use automation to your advantage. There's a lot of cool continuous integration, continuous deployment pipeline tools for checking things for like AWS secrets in your application. Use it to your advantage. It can speed things up. If things are changing hundreds of times a day, you're not going to be able to keep up with that with traditional tools. Use automation. So least privilege. One cool thing I saw just while taking screenshots and looking through the IAM console was this access advisor. So for each user, it will log what actions it takes and like what roles are used. I think it's for a year. It won't stop or keep logging stuff after a year. So in this case, I think this was my account, one of my accounts, administrator access. And then I did a couple things, and it turns out I only need EC2 and security token service. I didn't use anything else. So I could delete all of my other administrator privileges and only use these two things, and I would probably be fine. There's also a lot of companies that are coming out with open source solutions to this stuff. So Duo Labs has Cloud Tracker, which will track what actions you take and then recommend a policy for that. And Netflix does the same thing. They have a lot of cool security tools for AWS. So this one has, they set up kind of like default roles of like, you're a developer and you want to make an application, here's your role. And then after amount of time, they'll start taking away privileges that aren't used from that until they have one that kind of matches exactly what they need. So some resources. There's a lot of cool stuff. So Corey Quinn, his main business is focused on consulting for your AWS build to get it down, because that's very complicated. But he also makes fun of AWS a lot and has pretty good opinions on stuff like that. Rhino Security Labs is a pen testing company that focuses on the cloud, and they have a lot of cool tools, one of which is CloudGoat, which will spin up vulnerable misconfigurations in AWS, and you can go through and kind of find those, and they have explanations for all of those. The Expel blog has a lot of cool stuff about cloud and especially software as a service, like securing Office 365, which is pretty interesting. Netflix, like I said, has a lot of stuff, a lot of good talks online. They have their own security channel on YouTube. And then flaws.cloud and flaws2.cloud are kind of the same thing like CloudGoat, but they're hosted for you. So you can just go, it's like the hack this website kind of websites where you just kind of like poke around and you can find flaws in those applications. Any questions? Dang.